Hello, everybody, and welcome back to Unit 7 of Regents Chemistry, where we'll be talking about chemical bonding. So, today we will talk about the second type of bonding that we looked at, which is the metallic bonding. So, metallic bonds, as you might have guessed already, are the bonds between metals. Metals, as we know about them, lose electrons and make cations. So, the metals that we see every day, they basically have those electrons that just released from or that the metal atoms just lost, and then we have those cations. So overall, it's kind of like a free floating pool of cations and the electrons, and the attractions between those two things are what we call the metallic bonds. So this is what that pool looks like. As we just said, we have those, you guys see the cations like all around in the metal, and then we have the electrons that those metal atoms lost, and they are just kind of like floating free around those cations, and the attractions between these cations and those negatively charged electrons are called the metallic bonds. Now, that sea of electrons, those free floating electrons that we see in the metals, they actually explain a lot of properties that metals have. So the first thing that we know about metals is that they conduct electricity, right? And that is well explained by these free floating electrons, because the metals can conduct electricity because these electrons can move freely in them. So the more motion there is, the more the metal conducts electricity. And then we also know that metals are malleable and they are ductile, which means we can basically just change them into different shapes without actually breaking them. And these two properties are also well explained because of the mobility, or because of the movement of those electrons in that sea of electrons. Here's how that works. So here we are looking at a metal with the cation surrounded by the free floating or moving electrons. Now, let's say you apply force to those cations and you try to move them in the metal, because that's what we do when we are trying to like change the shape of anything. So here, when we are trying to move those cations, as you guys can see, the electrons that we have in the middle of those cations are also adjusting so that the cations are not right on top of each other. Because remember that concept of chemistry that we discussed in the chapter about atoms, that in chemistry, same charges repel each other, which means they cannot be together. So if you have same charges at the same place, they'll repel each other and they would really just want to go away from each other. However, opposite charges want to be together. So um, this pool of electrons that is in the middle of those cations, they kind of help them slide past and not be on top of the other cations. So that's why it's easier for the metals to change their shapes. Compare that with ionic compounds, which are solids for the most part, and they are organized in like very specific forms. So we have opposite charges placed at specific positions. So now let's say we are trying to apply force to the solid. When we do that, the same charges, there is a probability that the same charges can now be at the same place. They'll be on top of each other. And as we know that in chemistry, same charges cannot be together. They repel each other. So those opposite charges will repel each other. They would want to go away, and eventually those solids will break. So that's why when we apply pressure on an ionic solid, they will break rather than changing their shape. Okay, and finally, the last concept that we will go over regarding the metallic compounds are the alloys. So we don't normally use the metals in their pure form in like our normal everyday life. For the most part, we use the alloys. So alloys are basically mixtures of two or more elements, and at least one of them are metals. So those mixtures are made by melting those ingredients, melting all of those elements together and then cooling them. So here an example is brass, which is an alloy of copper and zinc. So the reason why we use the alloys is because they give us the properties that we cannot find in the regular elements or the regular metals. So for example, we use sterling silver, which is 92.5% silver and 7.5% copper. And that's because this is a little harder and more durable compared to like the pure silver. So even though it's a bit harder, it's still soft enough to like used in jewelry and stuff. Uh, but because the pure silver is a bit hard to use, that's why we use sterling silver. Alrighty, that's it for now. Uh, Good luck, happy learning. I'll see you guys in the next one.